Okay, mathematicians, so we are in 2.5. We're talking about end behavior. Anytime someone asks you about end behavior, you're being asked, where does this function go as x goes to infinity? Okay, they ask you about end behavior, that's what they're asking you. So let's look at the limit as x goes to infinity of 3x plus 2 over x squared minus 1. Let's go ahead and look at the rules that we just wrote down in our last video. And in this situation, it's clear that m equals 1, n equals 2. M is less than n. So let's go ahead and find that situation in my rules. And I see here my m is less than n. And when that is true, the limit equals 0 and y equals 0 is my horizontal asymptote. So you can go ahead and write here, this limit equals 0, y equals 0 is HA. I'm going to take another moment and look at this from another perspective real quick. So another way I might look at this instead of just looking at my rules is I know anytime I add or subtract some silly number like 2 or 1 from infinity, it doesn't really matter. So if I plug in this infinite into this x, I get 3 times infinity plus 2. Down here I'd have infinity squared minus 1. Right? These don't matter. Infinity plus 2 is still infinity. So I could just go ahead and kind of ignore those two. After I ignore those two, I see clearly that I can cancel the x in the numerator with one of the x's in the denominator. So I'm going to cancel out that 2 and cross that out. So now I'm looking at the limit as x goes to infinity of 3 over x, right? And so I have 3 over infinity, which equals 0, just like we said above. All right. Another example here, we have the limit as x goes to infinity of 40x to the 4th plus 4x squared minus 1 over 10x to the 4th plus 8x squared plus 1. And so if I go and I look at my rules, as we can see, both m and n equal 4. So my m equals my n. And so when that happens, we can see that our limit equals the ratio of the coefficients. And so does your horizontal asymptote. So that means that this is going to be 40 over 10 or 4. Y equals 4 is my HA. Another way to look at it is you can go ahead and multiply both the numerator and the denominator by 1 over x to the 4th. And we've chosen 1 over x to the 4th on purpose. X to the 4th is the highest power. And so when we do this, we see that we get, do you see what's going to happen? Right, we get 40x to the 4th over x to the 4th plus 4x squared over x to the 4th minus 1 over x to the 4th all over 10x to the 4th over x to the 4th plus 8x squared over x to the 4th plus 1 over x to the 4th. That cancels, that cancels. So we have a 40 on top and a 10 on bottom. And then this is going to go to 0, 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 right? These are going to cancel, and that's going to become 4 over x squared. These are going to cancel, that's going to become 8 over x squared. As x goes to 0, or excuse me, as x goes to infinity, this whole term goes to 0. Okay, so these can all cancel. You get 40 over 10, which is 4. Okay, let's do one more, and let's look at a slant asymptote. And so when we're talking about slant asymptotes, it's not horizontal, it's not vertical. Slant asymptotes are of the form y equals mx plus b. Right, so I have my coordinate. We have a line here. This is going to take the form of a linear function, right? Y equals mx plus b. So let's go ahead and look at f of x equals 2x squared plus 6x minus 2 over x plus 1. Clearly m is greater than n, so there's no HA, and the limit of this, the limit is x goes to infinity equals infinity. Okay, but let's go ahead and talk about the asymptote. Okay, so to go ahead and find the slant asymptote, first we're going to use long division. So we're going to put x plus 1 into 2x squared plus 6x minus 2. This x, we want to go ahead and get rid of this 2x squared. We want to get rid of the leading term. In order to do that, I need to multiply this x by a 2x to make 2x squared. I'm going to put that 2x here because I want these to line up. 2x times 1 is 2x. 2x times x is 2x squared. I subtract. I get 4x. I carry down the negative 2. Again, I want to get rid of this leading term 4x, so I'm going to make this a 4 here. I get plus 4 here. I get a 4x here. I subtract. That cancels. I get negative 6. So now I have 2x plus 4 remainder negative 6 divided by x plus 1. So that was first, use long division. Second, look at the limit as x goes to infinity of answer from 1 Okay, so we're going to look at the limit as x approaches infinity of 2x plus 4 minus 6 over x plus 1. Well, as x goes to infinity, this whole term over here goes down to 0. So as x goes to infinity, negative 6 over x plus 1 goes to 0. So the asymptote is 2x plus 4. Okay? The slant asymptote. So slant asymptote is 2x plus 4. So that is using some of our rules for end behavior, and that is the end of 2.5.